Hi everyone, this is Dikshit. Welcome to my channel. In this video, the idea is to discuss about the task that I had worked on in previous project so that it will give an idea how the DevOps work might look like. This video might help whoever started the career in DevOps and also people who want to start the career in DevOps. And also I would like to say it's not that you'll get the same task that I'm going to discuss in this video. Tasks might vary depending on project to project and also tools involved in the project. And this is a second video on daily activities. If you have not watched the first video, please do watch it. I'm going to provide the link in video's description. And before proceeding to the video, I have a small request. Recently, I have checked my YouTube analytics. I can see that only 25% of my viewers has been subscribed and other 75% of people who are watching my videos have not subscribed. It would be great if you consider subscribing to my channel. It will gonna motivate me to do more and more videos like this. Now, without wasting any time, let's get started. Let's start with scripting tasks. Before discussing about tasks, let me discuss about a problem statement. In one of the project, we had Jenkins as a CI/CD tool. The way Jenkins configured was for every 2 minutes, Jenkins will go and check the job queue. If any job run or like if any pipeline run stacks are present in job queue, so then Jenkins used to create a new node to run those particular pipelines which got stuck in the Jenkins job queue. So this is one of the best setup. It used to support so many pipelines to run at any given point of time. And also there was one more feature. If the node is not used for any other pipelines, if it is not used for 10 minutes, so then the node will be automatically deleted. So there was scaling up also, scaling down of the nodes were also there in this particular setup. And there were so many pipelines which were running in the Jenkins, where stages were very similar to the screenshot that is shown on the screen. The stages were like clone stage, static code analysis stage, build stage, test stage, creating Docker image, pushing Docker image stage, deploying KH cluster stage. And there are many other stages, many different pipelines were also there. But pipelines used to fail sometimes due to downtime of dependent tools like SonarQube, Artifactory, and Kubernetes. This created few issues. One was resource wastage because let's say if the pipeline fails at Docker push stage, so then pipeline would have already used the node around 40 minutes as shown in the screenshot for producing the negative feedback. And that too not due to developer build issue or a test issue. It is because of the downtime of dependent tool. And other main issue was developer feedback. If any issue with CI/CD tool or pipelines, then the feedback should be provided to the developer at the earliest so that we won't impact his productivity. So he can, so rather than checking the pipeline status, what he can do is he can work on other tasks as well. To solve these issues, we came up with an idea to add a stage which does health check in all the dependent tools like Artifactory, SonarQube, Kubernetes cluster, and many other dependent tools as well so that any dependent tool, if it is not running, so then pipeline will going to be stopped at the beginning itself. So by which we can provide the faster feedback to the developer and also which reduces the utilization of the resources by stopping the pipeline at the beginning itself. So this is where we had to write a script. So which checks the health of all the dependent tools. And then this is the script that was called in the pre-check stage. So if the pre-check stage is successful, then only it will go and execute other stages. If the pre-check is failed, so then the entire pipeline will be stopped and also the feedback will be given to the developer. And also on the other end, the resource utilization will also be reduced. Next scripting problem statement is we had a monitoring tool which scans the code and provides the information about security risks, license risks, operational risks, and also the list of code files as these issues. One problem with the dashboard is the dashboard had much information that can't be shared with the developers or even with leads. So getting access to the dashboard was difficult and also access would be provided only to the managers. But information like security risk, license risk, operational risk, and also the list of code files which has these issues, we wanted to show to the developers so that they can fix these issues and make code quality a little better. To do the same, we decided to show the information in Grafana dashboard so developers can easily access the data. But one problem was that we couldn't directly connect Grafana dashboard or like Grafana with a dashboard that had data because Grafana can accept only data from few sources like Prometheus, MySQL DB, InfluxDB, and few more other sources as well, but not directly with dashboard that we had data. So this is where we wanted to create a Python script which gets the data from the dashboard via API. And also after getting the data, which prepares the data and then insert the data into the InfluxDB. So once the data is inserted to the InfluxDB, so from the InfluxDB, getting the data onto the Grafana is easy. We added a data source in Grafana, and then we pulled out the data by executing influx queries onto the Grafana. And that is where we showed all the information about like security issues, license issues, and operational issues. So this dashboard was so useful for the dev team, by which they could make sure that the code doesn't have any security issues, license issues, and operational issues, by which we could able to make sure that the code quality is aligned with the company policies and also the code quality is better. Next scripting problem statement is, as I mentioned earlier, we had a Jenkins configured in such a way that nodes will be added according to the Jenkins queue. So this Jenkins setup was done in AWS. So to make builds faster, we had stored the caches in EFS. So whenever a new node or already existing nodes, that will be always connected to this particular EFS. Whenever the pipeline runs, then the caches from this EFS will be copied onto the machines, and then pipelines will going to use that caching and make the pipeline builds faster. And by using these caches, we achieved a great build time. So, but main issue was EFS was very costly, and also our cache was increasing day by day. So that's where we wanted to check, is there a way where we can reduce the EFS storage? And also we want to analyze it, because why every day the cache is getting increased. So that's where we analyzed the data which was there in the EFS, and we got to know one thing, that many files present in a EFS but not accessed since 30 days. So we wanted to delete those files which are not accessed since 30 days, so that we can reduce the storage in EFS. So this is where we had to write a shell script which scans the files in EFS and deletes the files which are not accessed since 30 days. And this script was scheduled every day to delete the files and to reduce the storage which is there in EFS. Next, let's discuss about Jenkins tasks. The first task that I want to discuss is installation of plugins. So here we were not simply installing plugins until unless like we have a very strong pain point or a use case. Sometimes we used to get pain points or use cases from developers, test engineers, and even from IR managers. So those pain points we used to analyze and search for the plugin which solves those particular issues. So one of the pain point or issue, so which is like some pipelines were there. So when that pipeline gets executed, which generates a lot of build logs, and the build logs were too huge. When developers try to access that entire log, so the Jenkins used to take much time to load and show the entire logs to the users or like developers or test engineers who are accessing that particular build log. And sometimes they have mentioned that even after 10 minutes, Jenkins page was stuck and the complete logs were not shown. And because of this, they were not able to see what was the issue the build failed with, and also they are not able to proceed with their activities. So this was a very important pain point for us. So that's where we wanted to kind of analyze and research this particular situation. So that's where we got one plugin. So that is Blue Ocean plugin. So we installed that particular Blue Ocean plugin on our Jenkins. So what Blue Ocean plugin does is it will gonna give you a better view where it will gonna shows the pipeline run in a very proper manner. It will gonna show stage by stage, and also it will gonna show the logs per stage, so that the loading issue of the Jenkins has been solved by installing the Blue Ocean plugin. And this was very useful for multiple developers and multiple test engineers, so that they can access the build logs early and they can find the issue why the pipeline has failed, or like is there any issue with their code. They could able to analyze it properly, and then they could able to move faster. And then the next pain point to install, or like main point to install job history plugin is, in some of the pipelines, many admins users used to change the configuration. So we wanted to have an audit who has changed what. So that's where the job history plugin we have installed, so that any job, if it is changed, so then we can see who has changed, what has been changed in a particular job. And then the next one is motivation to install the DSN plugin. As I mentioned earlier, some important pipelines were updated by many admin users, due to which pipelines used to fail. So this created a huge problem. Hence, we wanted something on a regular basis to update jobs with their default configuration. So that's where we asked all the teams to create a DSL job, and these DSL jobs will be ran on a regular basis so that all the jobs will be kind of applied with their default configuration. So to run this DSL jobs, we need to have DSL plugin. Without installing DSL plugins, we won't be able to run DSL jobs at all. So that's the main motivation behind installing DSL plugin. And then, to install next three plugins, we had a requirement from senior management. So to monitor metrics on how many pipelines in a day the Jenkins is building, success percentage, failure percentage, and other important statistics as well. So that's where these three plugins we installed, and by which we could able to extract the data and put it over InfluxDB and get the data from there and show it onto the Grafana. So by which where like many managers could able to see what is the status of a certain pipeline and what is the statistics of the particular pipeline. All those things were analyzed in that particular dashboard. And also, I've did a video recently where it was about monitoring Jenkins by Prometheus, Grafana, and InfluxDB. I have already uploaded it, and if you have not watched it, so please do watch it. I'm going to provide the link in video's description. Next task in Jenkins was preparing a Docker image, so it will help a specific pipelines to run. Sometimes a few pipelines needs a specific tools or frameworks like Java, Squish, Python with few module installations to be installed for execution. So for those requirements, we used to prepare a Docker file and create an image and push it to the private registry where Jenkins can pull that image and create the container and execute the pipeline. And here we used to create the image and push it to the registry. From there, Jenkins used to pull it and the creation of container, executing the pipeline, and after the execution of the pipeline, killing the container and all will be taken care by Jenkins itself. Next task is I was part of adding Jenkins nodes. Adding Jenkins nodes is easy, but configuring the machines with the required tools was the main work. For configuring the nodes, we used to write a lot of playbooks, which does all the configurations and installations. The installations tasks were like to install major tools like Docker, AWS CLI, Python, and Python modules. And also we had few configuration tasks also like creating the required users, creating required folders, and also uh, tasks related to copying the cache from EFS, connecting to the EFS, installing the certificates, which will help us to interact with dependent tools. All these tasks were created as a modules, and then these modules we used to run it over a node, and then we used to add it as a node to the Jenkins. Coming to the next task that I was involved in was reducing the build time of the pipeline execution. As a DevOps engineer, it is not always about only maintaining the infrastructure and creating a new pipelines. We should also make sure about improving the pipeline execution, like reducing the cost per build and also the build time itself. For this, we have used few techniques. So let me discuss about the techniques that I've used to reduce the build time. In some of the pipelines, clone used to take more than 5 minutes. So that's where we connected with the development teams and we asked them what are all the branches that they require to clone, and as well as like, do they require all the commits to be cloned? After getting that particular information, so we have used options like -FN single branch, -FN depth, and also -FN references. So by using these options, we could able to reduce the clone time from 5 minutes to 1.5 minutes. Next improvement was we were using Docker container as an agent for most of the pipelines. In this case, if Jenkins node is new, so then Docker image referred in the Jenkins files might not be available. So Jenkins will try to pull the image in the pipeline execution itself. Even the pull time is added to the pipeline execution time. So let's say if the image is bigger, so then it will gonna take a lot of time to pull. And as well as sometimes pulling the image used to time out because in Docker plugin, we have a setting. So if it crashes so and so time, so it was by default, I guess 30 seconds. If it crashes 30 seconds, then the entire pipeline execution is set to aborted. So to avoid these kind of issues, while creating the node itself, we used to pull the image and keep it in the node so that while executing the pipeline, node never tries to pull the image again. So as we have pulled already images, right? In the pipeline execution, it uses already pulled images and executes the pipeline faster way. Next technique that we have used to reduce the build time was implementing caches. So wherever it is possible, we have introduced caches like Maven cache, C cache, Node.js cache, and there were many other cache types as well. So what we used to do is we used to store all these caches in EFS, and when new machine gets created, and for those machines we used to copy the cache, and then once the cache is copied in the pipeline execution, these cache files will be referred and the execution will be faster. Another techniques in our Jenkins, the node size was quite big, but in many pipeline runs, we have observed that the pipelines was using a less CPUs. So it's like we have resources in place, but we were not using it. So that's where we suggested all the pipeline execution teams to increase the number of threads so that the pipeline execution will become little faster. And one more, the last technique that I would like to share is we had few pipelines where we had couple of stages. Those stages were not dependent at all. So when there is a stages which are not dependent, so then rather than executing them in sequential order, we can execute it parallelly so that we can utilize the resources in a proper way, and also we can make the build execution of the pipeline little better. Next, let's discuss about cloud-related tasks. In one of the project, I was part of infrastructure provisioning team, where the project was more into containerization. So that means many deployments were happening on Kubernetes cluster, and we were using AWS cloud mostly there, and also the entire infrastructure, the services that we were using was created through Terraform and TerraGrant. As I mentioned, the project was more into containerization. We created a couple of EKS cluster in different environments like QA, prod, pre-prod, dev environments. And also each EKS cluster was not used for same purposes. So each EKS cluster was used for different purposes as well. So purposes like EKS cluster to deploy CI/CD tools, EKS cluster to deploy applications as well, and EKS clusters to deploy few of the security related tools. So for those things also we created a EKS clusters. But all these EKS clusters were created through Terraform and TerraGrant. And when I say EKS clusters, it is not simple one. We used to have a different node groups and different type of machine configurations. So let me talk about architecture of one of the EKS cluster that we created for installing CI/CD tools. So there we had 4 node groups. The first node group, we had a couple of machines of type M and R series because we wanted to bring up Jenkins in this node group. As Jenkins is a memory intensive application, R and M series will go well with memory intensive application. So that's the reason we created a node group with M and R series. And also Jenkins was deployed on a Kubernetes cluster. So we had 2 types of nodes. One type was creating the pod and running the pipelines on those particular pod. And these pods were created in different node group where we used to run some admin related to related activities pipelines, and also some simple pipelines we used to run it on these particular pods. The other type of nodes were being a very big EC2 machines because we couldn't accommodate a few of the pipelines to run on pod. So we had to definitely create a big EC2 machines. So that's where so Jenkins used to monitor the Jenkins job queue, and whenever there is a pipeline run which gets stuck at job queue, it used to read that particular information, and then it had a library. So it was going to call that library and it used to create the machines in the cloud, and then it used to provision it as a Jenkins node, and it used to execute the pipelines. And we had a third node group where machine types was T series, but it was bigger machines. I mean, resources like CPU and memory was huge, and where we deployed monitoring stack like Prometheus, Grafana, and InfluxDB. Again, so we were using monitoring stack heavily because we were monitoring EKS clusters and also the EFS. So what is the storage, what is the throughput at any given point of time? And we were also monitoring all the CI/CD tool status, whether it is up and running or not, and especially the pipeline statistics like how many pipelines execution ran, success percentage, failure percentage, and more details about the pipeline. We used to display it on the Grafana dashboard. And the fourth node group was like A series and AMD machines, which offers balance between CPU, memory, and little faster compared to other machine types. So this node group is used for like SonarQube and Artifactory because we need machines where we can deploy SonarQube and Artifactory, which will be faster because Artifactory and SonarQube will be used in many of the pipelines. So that's why we chose AMD series and we deployed the SonarQube and Artifactory. Also, all the CI/CD tools deployments were also done through Terraform itself. For this, we have used Terraform Helm provider. As we add a couple of environments, we used TerraGrant. TerraGrant is a wrapper of a Terraform, which helps us in deploying the Terraform code across multiple environments. On top of this, we used to get the request to change many machines, machine configurations, configs of CI/CD tools, even that were taken as a part of tasks, and then we used to apply the changes via code itself. We never used to deploy anything manually, so everything go via Terraform and TerraGrant, and then only it will be deployed. As I mentioned multiple times, I've used EFS to store caches. To manage and configure EFS, we had used Terraform. And a couple of S3 buckets were there. So there we used to store the files which are related to pipeline execution. Even those were managed to Terraform itself. So that's it for this video. So if you have liked the video, please like, share, and subscribe. Thank you. Have a great day.